Hello everyone, this is Mr. Ahmed Al Qadri, and today we will continue our lesson about compounds and chemical changes. And today we want to talk about chemical changes. Of course, you are studied before about physical change and what is the difference between physical change and chemical change. So, in physical change, only there is a change in the shape or size or position of an object. But in a chemical change, there's occurs when an atoms link together in a new ways to create substance different from the original substance. As example, if I cut a paper, so the paper is still paper, so it's shaped only in the size of the paper. It's become smaller. But in chemical change occurs when I have a new substance. Another example, if we take the vinegar and we froze it, so it would still be vinegar, just in a solid form, as long as you are only making physical changes. The vinegar will always be vinegar. So, if you combine baking soda with vinegar, a chemical change occurs. The baking soda changes and bubbles form. The bubbles are a new substance. Also, a new white solid is left behind. The new substance that formed have different properties than the vinegar and the baking soda. The bubbles are a gas, and the white salt does not react with vinegar. So during chemical reaction, atoms in the baking soda and vinegar link together in a new way. This forms sodium acetate, water, and carbon dioxide. The bubbles formed from the reactions are carbon dioxide. The white solid is sodium acetate. So look at this reaction here as example. So baking soda and vinegar reaction. So the atoms, they are rearranged together and making a new substance, as you see in this chemical equation. Okay guys, in studying math you probably have seen equations like 2 plus 6 equal 8 or 3 plus 7 equals 6 plus 4. So this is adding equation. So chemist writes equations for chemical chains similar to math equations. For example, hydrogen gas and oxygen gas combine to form water, as you see in this picture right here. So water forming reaction. This is hydrogen and oxygen, and give me water. So this is a chemical reaction. A chemical reaction keeps track of which substance are used and in what ratio. So the number in front of the chemical formula tells how many of those molecules are used. Like example of this number, that means I need two molecule of H2. They have two molecule of H2, and I don't have any number here. That means I have only one molecule of O2, and it will give me two molecule of hydrogen. Look at over here. Molecule here are the same as the atoms for the element. The molecule are the smallest part in a compound and still represent this compound. So the chemicals on the left side of a chemical equation are called reactants. So in this example of water forming reaction, so the reactants are hydrogen and oxygen, and the chemicals on the right side of the equation are called products. So in this equation the products are water. Another example, if we want to take another example of for baking soda and vinegar reaction, the reactant in this equation are sodium bicarbonate or baking soda with vinegar. Okay, these are the reactants, and the products are we have water, carbon dioxide, and sodium acetate. So, okay, guys, in math equation, the left side must equal the right side. How does the left side of a chemical equation compare to the right side in a chemical equation? So the total mass of the reactant equal the total mass of the product in a chemical reaction. So this is known as the law of conservation of mass. So in other words, the total number of each type of atoms must be the same in the reactant and the product. As example, you can see here, I have 4 atoms of hydrogen and I have 2 atoms of oxygen in the reactant. So in the product, let's us see, we have 1, 2, 3, and 4 atoms of hydrogen. Also, I have 2 atoms of oxygen. That's an example of the conservation of mass in a chemical reaction. So math equations make sense whether you read them right to left or left to right. Chemical equations are similar, so most chemical chains are reversible, so or they can be undone. When a chemical reaction is reversed, the products break apart or combine to form the original reacts. Water can be broken down into hydrogen and oxygen gas.